Hey, what's going on? It is Sunday, June 19th, 2022, and welcome to Chef the Leetcode Guy. I am here back from a long hiatus of taking a break from doing these coding videos and other media, and I've just been dabbling in a few other things and just trying to get back into the swing of things. So I feel like I should just start with an easy problem. And by the way, if you like my videos, please like, subscribe, and click on the link below. This is just kind of like one of those warm-up things that I'm just doing to kind of get the blood flowing and get back into the swing of doing regular videos. So yeah, keep looking out for a new video every day. I've got the solutions up, and I've been trying to get a mix of easies, hards, etc. Most of it kind of to work that explanation muscle, which is really important and lacking in a lot of engineering disciplines. And just in general, it's good to practice explaining stuff, right? For interviews and in general for your job, etc. Okay, so this is the problem called joules and stones. 771. It's an easy problem, and no doubt it is. You're given strings joules representing the types of stones that are joules, and stones representing the stones you have. Each character in stones is a type of stone you have. You want to know how many of the stones you have are also joules. The English on some of these things, the grammar needs editing on these questions, but it's fine. Letters are case sensitive, so lowercase a is considered a different type of stone from uppercase A. So let's just quickly talk about how we could do this brute force. So there's a brute force solution to this where you are iterating through every stone, right? Through every joule, you're checking whether the stone is a joule. So you have your stones, you have your outer for loop where you're going through A, capital A, B, 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 and checking, okay, iterate through each of the joules, A, and look at the next joule, A, and then just the time complexity is the number of stones times the number of joules. And obviously we don't want to do something like that. It says here all the characters of the joules are unique. And so yeah, what we can do is, obviously this is plain old hash set problem. This is actually probably one of the first problems you would want to do if you want to understand how dictionaries work, right? So and the advantage of using dictionaries. So basically what I'm going to do is start off by saying, okay, well, as I said, we're going to use a dictionary. In Java, that's a hash set, or a hash map. Hash map is actually a dictionary. A hash set is kind of like a half dictionary, just the set part, the fast contains lookup part. There's no count maintain. So basically the reason I'm doing this is because I don't have to iterate using this set. I don't have to iterate through each of these joules every time I want to check whether a stone is a joule. I can just immediately look into this set and see, yes, does it contain it, and so on and so forth. So this reduces the time complexity. The original brute force time complexity I mentioned was the length of the joules times stones, and that's too slow. That's pretty slow because we don't want to do that iteration. That could get pretty large. In this new time complexity, we're just looking up the number of joules plus the number of stones. And why plus? Because with this joule set, all I'm going to do is I'm going to store the number of joules here, and that's just going to take an iteration through the number of joules, and then I just have to, in a loop afterwards, I just have to look up which joules are stones, or which stones are joules. Okay, so first let's do the O of joules part. Okay, joule set I. Now, this is just adding to the joules set, right? So all my jewels are now contained. Stones. Now what I'm doing is I'm iterating through each of the stones, and I am seeing if the jewel set just contains the stone, right? This is an O of 1 internally an O of 1 lookup times the number of stones equals O with the number of stones, and then return total, which is the total count I'm incrementing whenever there's a new jewel that is a stone found. Okay, or stone that is a jewel. Let's run it. Jewels. Okay. 3, and then run this, and then okay, great. So, yep, not the fastest. We can improve upon this probably by converting this jewel set into a Boolean array of characters. I'm not going to do that now, but you can do that as an exercise. You do something like Boolean here, and then let's say 256 for the number of characters. Jewel set equals. Let's see if this improves the time complexity any. Let's say 250. Let's see, 256. We don't need 256. We can do an optimization there, but we're just gonna do this real quick and just see if this works. Jewel set equals true, and then we just check if jewel set dot. All we need to do is check there, and if jewel set return let's see, jewels dot length length. I will take that away. Okay. And lo and behold, that's a lot faster. Okay, so just taking a quick picture of this, because yes, this is, so sometimes just using a set is much better than using a map, especially since we're constrained by the fact that these are characters. And I just wanted to show you that there's a huge improvement, and in certain interview situations that may impress your interviewer, that you can do kind of things like that. And why would there be an improvement? Because the set data structure has some overhead, right? So possibly for adding elements into the set, and also for checking, there's a slight amount of constant overhead which adds up over time, but these are still, the operations are still within the constant time to linear time in the number of stones and length of jewels operation, right? So, but the space here is pretty much fixed in this case, right? Because we're always just initializing an array of 256 characters. Okay, so that's it. If you like my video, please like and subscribe, and let me know how I'm doing, comment, and yeah, I'll see you around. Have a good